Okay, so this is OCR A-Level Chemistry F324 paper, June 2010, and this is a question about analysis and spectroscopy. So for question 3a, student has been given three compounds to identify. There's an aldehyde, a ketone and a carboxylic acid. And if we read it carefully, we need to describe two chemical tests that will allow the student to distinguish between all three compounds. We also need to show what the observations would be for each. So I've already pre-populated this as the two tests that will specifically identify one of these. What I've not mentioned at the moment is anything involving 2,4-DNP, otherwise known as Brady's reagent, because this, which will give an orange precipitate, would still leave you as having either an aldehyde or a ketone, because it identifies the carbonyl functional group. So that is a bit of an extra. What we'd start by doing, aldehyde test, is Tolan's reagent, 1 mark, and this would give us the silver mirror. So again, we're looking here to mention the actual observation. So Tolan's reagent identifying the aldehyde by the formation of a silver mirror. So at this point, you've got two chemicals left. You would do the carboxylic acid test, which is where you would add carbonate ions and you would get some bubbles. Okay, on to part B. Explain how the student could use infrared spectroscopy to confirm which compounds are carboxylic acid. What you've really got to do here is state the bond that you're looking at. So crucially, we're going to be looking at the OH here, which all three of the chemicals have got a carbonyl, but only the carboxylic acid has got the OH, and you would be stating the range that you would expect it in, put in that keyword bond, and let's also show that we know that it's going to be a broad peak. Right, on to the main bit this video is for, it's the NMR. So, we're told that we've got an aldehyde with the formula C5H10O. Now let's have a look. There's no spectrum given this time. Instead, there's just some information about it. It tells us that we've got a doublet, 0.9 ppm, which is a relative peak area of 6 when compared to the aldehyde proton. So we know there's just one of those, and so we know there really are 6 and there's no further multiples here. We've got to use this information to deduce the structure of the aldehyde. Now, I've prepared some extra information earlier. Here are the key parts from this. Now the first thing we're going to look at is the chemical shift, and so we know that this is RCH, that is this environment here. The relative peak area of 6 tells us that there are 6 equivalent hydrogens, and the easiest way for us to get that is if we've got two methyl groups bonded either side of a carbon. Now we're going to look at the splitting. The doublet means that n plus 1 equals 2, so n equals 1. Now we need to state what that is. We need to show to them we know exactly what that means. So that means there's one hydrogen on the adjacent carbon. So here is the adjacent carbon, and so there can only be one hydrogen here. Now at this point in the mark scheme, doing all this will have got you 2 marks. If we have a look up here, we know that the aldehyde's formula is C5H10O. The functional group gives us 1 hydrogen, 1 carbon and 1 oxygen. So you always want to be subtracting the bits you've identified away from the total. It means we've got C4H9 in the rest of the molecule. We've just worked out here that we've got C3H7. 1, 2, 3 carbons and the 7 hydrogens. And that means that there's a CH2 somewhere else, and this is probably the most common mistake here, where people forget about this CH2. So what you've got is your aldehyde at one end, then you can have the CH2 because there's only one connecting part here, one connecting part here, the CH2 in the middle, and that is your molecule there. Okay, last part of this one. We're told that the ketone also has that formula C5H10O, and there are 3 structural isomers. 2 of them are drawn for us here, and we have to do the third one here, starting off with the carbonyl. These two each start with just CH3 on the right hand side. We've done all the possible combinations here, so let's try having an ethyl, a CH2, CH3 on that side. 5 carbons needed in total. Got 3 here, so we need another 2 to make it C5H10O. Okay, the carbon-13 NMR spectrum is given below, and you've got to identify the ketone. Now the very first thing you should be looking for is how many peaks there are. There are 4 peaks, so there are 4 carbon-13 environments. That gets you 1 mark just for spotting that. Now we're going to go up here, and we're looking for symmetry. Remember, this molecule is asymmetric. There's not the same number of carbons on the left as on the right of the carbonyl. So 1, 2, 3, 4, 5 different carbon-13 environments. For this one, we've got 1, 2, 3, and these 2 here are going to be equivalent. So that one is 4 for the carbon-13 environments. And then this one here, it is symmetrical about this central carbon here. So if I say that's 1, add aside are equivalent, and again this is equivalent to that one. So this one would give you 3 environments, or if we do it the other way around, that would give us 3 peaks, which means with 4 peaks down here, it is ketone 2. And at this point, make it really clear, equals ketone 2, or actually put the structure in. Now there's an extra part we can do just to be convinced that we're correct. This peak is double the height of the other ones, which tells you that there are the 2 equivalent carbons in it. Now let's read the full question. And if we see here, we've identified the ketone, we've explained our reasoning, because it's got 4 environments for the 4 equivalent carbons. And now we have to identify the carbon responsible for the peak with a chemical shift of 210 ppm. Refer to your data sheet, and this is the aldehyde carbon. Okay, thank you very much for watching.